Hello my dear students. So today I am going to discuss electrophilic aromatic substitution with you. It is an organic chemistry reaction mechanism part. So let us start electrophilic aromatic substitution. So in electrophilic aromatic substitution, basically the brief form of electrophilic aromatic substitution we write EAS. Okay. So basically benzene and benzene related derivatives, they give generally electrophilic aromatic substitution reaction. So what does it includes? It includes the basic model of the reaction. I am taking a standard reaction, that is benzene. When benzene reacts with chlorine in presence of AlCl3, it forms chlorobenzene. So this is the basic reaction of my benzene with chlorine and AlCl3. Okay, so then the byproducts are this HCl and AlCl3. Okay, so now what happens here, how it occurs? We describe this mechanism in three parts. So first steps, so I am writing down all these three steps for you. Okay, so before going further, by knowing the mechanism of any reaction, we can say that when benzene is reacting with any electrophile, for say like Cl plus, NO2 plus, Br plus, any electrophile is coming in the contact with benzene, then benzene will be, you can say that it will react in a similar way like Cl plus is reacting with this benzene. So how it follows? Then step number one is that generation of electrophile. Okay, so it is generation of electrophile. So now in generation of electrophile, for when we say the generation of electrophile, what does it mean? It means that we need some reagent. Reagent produces electrophiles, reagent produces nucleophiles, and reagent produces free radicals. So here we are generating electrophile in a separate container. First we generate it, and then we will attack, or you can say add that electrophile mixture over the benzene, right? So what happens here? This is chlorine gas. So chlorine gas is a non-polar molecule. Chlorine gas is a non-polar molecule. If we say that it does not need AlCl3, then how we will going to break it? It will not break it, right? So if we have to create polarity in the Cl2 molecule, then what we will do, that we have to bring some you can say charge difference over this Cl2 bond, CCl bond, right? So when then we bring AlCl3 in picture, here what AlCl3 does, AlCl3 basically is our Lewis acid. It has incomplete octet. AlCl3 has 6 electrons in its outermost shell. So it is, you can say it wants to fetch electrons. It is in the you can say search of electrons. So when it comes in contact, it comes near to Cl, it interacts with this AlCl3, and then it starts polarizing this Cl2 molecule, and a partial negative or partial positive builds up over the Cl2, and in due course what happens, that this bond, these two electrons get shifted over this Cl2 molecule, this Cl, and this Cl is, it becomes Cl positive, and what it becomes, this becomes is AlCl4 minus. Okay, So by this, adding AlCl3 over a non-polar molecule, we could generate Cl plus electrophile, and electrophiles are those which are electron deficient. So they are electron loving species, you can say. So now it will be, you can say, a nucleophile can easily attack over the electrophile. So when we say a reaction is happening, basically what is happening here? So a nucleophile reacts with electrophile and it forms the product. So now our electrophile is ready. Now the step 2. So step 2 is what? Step 2 is you can say attack of electrophile, right? Attack of electrophile. In general, what happens that now we add this electrophile mixture in a container where we have taken benzene. So now what is the nature of benzene here? It behaves as a nucleophile. It acts as an electron rich species. Because it has an electron cloud over the plane of benzene. You can say that the electron cloud is here and below the plane of C. This skeleton is hexagonal planar structure, right? H. So electron cloud is hovering over these 6 carbons and this 6 carbon ring, and electron cloud is hovering behind the plane also. So it acts as a, you can say, electron rich system. Now it can easily attack over the Cl plus electrophile, because in organic chemistry attack always happens negative to positive. So now benzene, for say, you can say it is when chlorine plus is coming in contact with benzene, then what happens? This pi bond electromeric shift happens and this negative charge builds up and it attacks over the chlorine plus. So it results in the formation of a intermediate which is known as arenium ion, So it remains intact. So now benzene is an aromatic compound. When this aromaticity now is broken of the benzene and it has formed our arenium ion. And for this electrophilic aromatic substitution reaction, this is also our RDS step. What is RDS step? Basically, it is a rate determining step. It is one of the, you can say, it is the slowest step. So what we have done till now, that we, in a separate container, we have generated our Cl plus. So this is a step 1 separate. In a test tube or something, we have generated Cl plus. Now in a separate container we have taken benzene, and in benzene test tube we added slowly our electrophile mixture that contains Cl plus, and it breaks the aromaticity of this benzene, and it breaks this by breaking this pi bond. This chlorine is added here. Now since it is an intermediate, it is you can say it is a reactive intermediate, and this intermediate is stabilized by its, you can say it is cyclohexadienyl cation. It is cyclohexadienyl cation. Now it is stabilized by resonance. So resonance is still happening here. Here positive builds up, and then this pi bond shifts over here and it will show resonance. Positive charge will be shifted over there, and then final step comes up, what is for the final step here? Final step is step number 3. Step number 3 is that restoration of aromaticity. Means now how restoration of aromaticity will be there? This hydrogen now will be eliminated. What is the driving force behind this elimination of H plus? Is the restoration of aromaticity. So third step becomes expulsion of proton. In standard books you will just see that these are the basic titles of these steps, that generation of electrophile, attack of electrophile, expulsion of proton. So I am also writing these standard steps also, titles also. And now what happens? This benzene, that H and Cl, to again it wants to restore its aromaticity. Therefore these two electrons will become a part of this aromatic character, and it will form once again an aromatic compound, that is a chlorobenzene. And how H plus will be taken up? The AlCl4 minus again comes up, and it will fetch this H plus, and it will taken up, and it becomes HCl AlCl3. So now we have what we have done in, we can summarize this. What we have done basically, we have done this H is substituted, by Cl plus. So ultimately this H plus is substituted by Cl plus. An electrophile is substituted by another electrophile. So this is all about that is why we can say it is electrophilic aromatic substitution. On an aromatic compound we have taken an electrophile which is substituting an electrophile, and another electrophile is coming up. Therefore overall it is electrophilic aromatic substitution. Now various electrophile we can take, like for nitration of benzene we generate NO2 plus. In sulfonation of benzene we take H2SO4, conc H2SO4, and for the generation of Br plus we take Br2 and FeBr3. So like this all steps are common, but electrophile changes, and by that we can form our product. Okay, so in later classes we will discuss more details about this reaction, and various examples we will take. Okay.